Today the topic that we are going to cover is the first of all shortcut formulae for of uncertainty. So the topic today we are going to cover is first of all shortcut formulae for the calculation of uncertainties. The first formula that we need to discuss is for addition. If two values are added, then their uncertainties, if two values are added, then their uncertainties are added to. So if we add two values, then their uncertainties will also be added. Just for example, if we have x is equal to a plus b, we have two values a and b which are added to make x. Now you see the uncertainty in x will be equal to the uncertainty in a plus the uncertainty in b. So uncertainty in x will be equal to uncertainty in a plus uncertainty in b. So if the values are added, then uncertainties are added as well. Number two, if the values are subtracted, then uncertainties are still added. So even if you subtract the values, still the uncertainties are still added. For example, if you have two values a and b which are subtracted, then their uncertainties will still be added. So even if two values are subtracted, their uncertainties are still added. This was the formula for addition and subtraction. Now what about the product? If two values are multiplied, so when two values are multiplied, just for example, if x is equal to a into b, so this is a situation in which two values are multiplied, then the sum of fractional then the sum of fractional uncertainties of A and B, then the sum of fractional uncertainties of A and B, then the sum of fractional uncertainties of A and B will be will be equal to the fractional uncertainty of X. So basically, if X is A into B, then fractional uncertainty in X will be equal to fractional uncertainty in A plus fractional uncertainty in B. Sum of fractional uncertainties of A and B will be equal to the fractional uncertainty of the answer of the product. Now, if the values are divided, if two values are divided, for example, if X is equal to A over B, you have two values A and B, you divide them to get the answer X, then what would happen? If two values are divided, for example, if X is equal to A over B, then the sum of fractional uncertainties of A and B will be equal to the fractional uncertainty of X. So if two values are divided, then the sum of fractional uncertainties of those two values will be equal to the fractional uncertainty of the answer. Basically, what we are saying is, if you have X is equal to A over B, then fractional uncertainty in X will be equal to fractional uncertainty in A plus fractional uncertainty in B. Whenever two values are divided, sum of their fractional uncertainties will be equal to the fractional uncertainty of the answer. This is the principle. Now, number 5, rule for power. While writing a formula for uncertainty, the power will become the coefficient. Just for example, if X is A power 3, now X is a quantity that is equal to A power 3. What would be the uncertainty in X? Now, by principle, fractional uncertainty in X will be equal to 3 times of fractional uncertainty of A. Now the important thing is, in the uncertainty formula, the power becomes the coefficient. So power becomes coefficient. So whenever you write a formula for uncertainty, the power in the formula will become the power in the formula will become the coefficient. So that is the main thing. So in uncertainty formula, the power becomes the coefficient. So whenever you write a formula for uncertainty, the powers in the original formula will become coefficients in the uncertainty formula. For example, if x is equal to a cube b square over c5, then the formula for uncertainty will become, then uncertainty will be equal to, as you see, it would be delta x over x is equal to 3 times delta A over A. So in the original formula, A has power 3. So that 3 becomes the coefficient of the term that contains A. So 3 times delta A over A plus 2 times delta B over B plus 5 times delta C over C. So this is the formula for uncertainty. So the powers in the original formula will become the coefficients in the uncertainty formula. That is the main thing. Now you see, the last rule that we'll study is about coefficients or constants. Coefficients or constants. We have different rules for coefficients and constants in case of addition, subtraction, multiplication, and division. First of all, in product, division, and power, in case of these three operators, in case of product, division, and power, the constants, or you may call them coefficients, the constants or coefficients in the original formula, the coefficients or constants in the original formula are ignored while writing a formula for uncertainty. So whenever you write a formula for uncertainty, the coefficients in the original formula are ignored. So this is the main principle. Let's suppose you have, if x is equal to 3 times AB, then you see, when you write formula for uncertainty, this 3 that is coefficient will be ignored, and the formula would be, you see, delta x over x is equal to delta A over A plus delta B over B. So in product division and power, the constants that are present are ignored while writing the formula for uncertainty. Now let's suppose you have x is equal to 5 times AB over C. You see, this is product and division. So this 5 is, ignored. As we discussed right now, this 5 is ignored, and the formula would become then, you see, delta x over x is equal to delta A over A plus delta B over B plus delta C over C. This 5 has nothing to do and it is ignored. Now, for example, you have, if x is equal to 3 times A cube into B over C power 4. Now, two things are important. First of all, the coefficients, this coefficient 3 is ignored. So the first thing is ignore the coefficient. And the second thing is the powers will become the coefficients. Now one thing, since both numbers are 3, so you may get confused. So I should use a different number here. Let's suppose this is 4. Now you see 4 is the power and 3 is the coefficient. So first of all, the coefficient will be ignored and the power will become the coefficient. The formula for uncertainty will become delta x over x is equal to 4 times delta A over A plus delta B over B plus 4 times delta C over C. So constants are ignored and powers become the coefficients. So this is the rule for product division and power. However, in case of plus and minus, in case of plus and minus, the constants are not ignored. For example, if you have, if x is equal to A plus 3B minus 4C, then absolute uncertainty in x will be equal to absolute uncertainty in A plus 3 times absolute uncertainty in B plus 4 times absolute uncertainty in C. So the coefficients in the formula for addition or subtraction will remain there. Now let's suppose you have, if x is equal to 3a plus 4b, then the formula for uncertainty would become absolute uncertainty in x will be equal to 3 times absolute uncertainty in a plus 4 times absolute uncertainty in b. So these are the rules for uncertainty calculation. Let's go for a quick revision. Basically, today we have studied the shortcut formula for writing uncertainties. The first thing that we studied was, if the values are added, the uncertainties are added too. The second formula that we studied is, if the values are subtracted, then the uncertainties are still added. You see here, the values have been subtracted, still the uncertainties are added. The third formula was for product. When you multiply two values to achieve the answer, then the fractional uncertainties of those two values will be added up to get the fractional uncertainty of the answer. So if x was equal to a into b, then fractional uncertainty in x will be equal to the sum of fractional uncertainties of a and b. Now, the fourth formula was about division. Whenever you have two values which are divided, here a and b are divided to get another value x, then the sum of, then you see that the sum of fractional uncertainties of the values which are divided will be equal to the fractional uncertainty of the answer. Basically, for product and division, we have same method to calculate the fractional uncertainty in the answer. Then number 5 was power rule. Power rule is basically in the uncertainty formula, the power becomes the coefficient as you see here. And then number 6 was about coefficients or constants. In product, division, and power, whenever you have product, you have division, or you have power, the constants or the coefficients will be ignored while writing the formula for uncertainty. While in case of plus and minus, the constants will remain there while writing the formula for uncertainty. These are the rules for uncertainty calculation. We'll solve some examples later on. However, let's move on with the notes right now. The next topic that we have to cover is precision and accuracy. The next topic that we have to cover is precision and accuracy. Basically, precision and accuracy is about quality of the data that we collect. No data is correct, no data is incorrect, or you can say that an experimenter cannot comment on the validity of the data. However, we can comment on the quality of the data. Two things are there which we consider. One thing is consistency, repeatability. If an experimenter is able to achieve the same value again and again with no difference, then he is very precise. He's precise. And if an experimenter is able to achieve an average which represents the actual value, then he is accurate. So when you say someone is precise, it means that he's able to repeat the obtained value again and again. While when you say he is accurate, it means that the average of all the values he achieved is same as the actual value. So this is the definition of precision and accuracy. And precision and accuracy is related to the quality of the data. Now, first of all, if you look for this, let's define precision. What is meant by precision? Precision is basically degree of closeness, degree of closeness of the readings in an experiment. So how much close the readings are with each other, it is called the precision of the experiment. So if you are getting same value again and again, then you are precise. Your experiment must not have fluctuations. So basically, an experiment an experiment with less fluctuations will be a more precise experiment. So an experiment with less fluctuation will be a more precise experiment. You must know that. For example, if two students calculate a value for G and one student calculates a value of 3 all the time, you know that a value of 3 is not correct, yet the student is able to repeat that value. Whatever his error was, it is consistent. So the other student calculates values, let's suppose 9.6, 9.8, then he calculates, okay, 9.9. Now you see the second student is closer to the actual value, yet he's not precise. Precision is not about validity, correctness, or being closer to the actual value. It's only about repeatability. It's only about consistency. So you see here, this student number 1, although he's incorrect, yet he is precise because he is able to repeat his values, while student number 2 is less precise. The reason being, he's not able to repeat his values. For example, student number 2 is closer to the actual value, but precision has nothing to do with that. Precision is only about the repeatability. So student number 1 is more precise as he is able to repeat his values. Now, for example, if you get a situation in which some students collect data for the calculation of a quantity and their data are plotted, and what you see was, let's suppose, what you see was one of the students achieves this data, the other student achieves this data, the other student achieves this data. So data achieved by student number 1 was this. The data achieved by student number 2 was this. The data achieved by student number 3 was this. Now you see, student number 1 has no fluctuation at all, and student number 3 has maximum fluctuation. If you look for the results obtained by all the 3 students, then the results obtained by student number 1 has the least fluctuation, hence it is the most precise one. So if the data has less fluctuation, then it is more precise. And student number 3 is the least precise. So data achieved by student number 3 is the least precise, and data achieved by student number 1 is the most precise. That is the main thing. So this was about precision. Precision is about repeatability or consistency. Now let's define accuracy. Accuracy is about being close to your target. Accuracy defines basically, you can say that it is degree of It is degree of closeness of the average of the data to the actual value. So if you get a data in which the average is close to the actual value, then it is an accurate experiment. Just for example, two students perform an experiment to calculate G. Data obtained by student number 1 was he always achieved a value of 7. So his average will be, as you see, 7 meter per second square. Second student achieves values 5, 10, 15. Now you see the second student is not a precise one, yet his average will be 10 meter per second. 10 meter per second square. Now you know that the actual value of G on the surface of Earth is accepted to be 9.81 meter per second square. The results of the average of student number 1 is away from the actual value, while the average of student number 2 is close to the actual value. Hence, we can say that student number 2 is more accurate. Student number 2 is more accurate as his average is close to the actual value. We are done for today. Tomorrow, the topic that we'll cover is calibration curves. And then we are done with this chapter. And from day after tomorrow, we'll start the new chapter that would be kinematics. So topic for tomorrow will be calibration curves. Take care, students. Khuda Hafiz.